My dear friends,
The
my
flow
dear brother
is
and sister,
streamlined. The
we
flow
will
is
start new chapter.
streamlined.
P Black Elements Part 2. P Black Elements Part 2, okay?
Streamlined.
We will be studying in this chapter the fluorenes, carbide, fluorocarbons, silicates, structural principle, tetrasulfur, tetranitride, basis properties of halogen and interhalogens and polyhalides, okay? Fluorenes.
Does not exceed a particular exceed a particular value called particular
Fluorescents are
value
newly allotropes of carbons which were discovered in 1980, which are molecular and have a spherical cell structures. Fullerene has the formula C60, but C17, C76, C64, and others are also known. The most common Fullerene has spherical molecules in which 60 carbon atoms are joined together. Okay?
greater than the critical velocity.
Chemist name this perfect sphere as Buckminster Fullerene after the American architect. Okay? American architect Buckminster Fuller who designed such domes that have hexagon and pentagon to provide rigid structure with three-dimensional geometry. Hence, name Buckminster Fullerene is related to the designer of geodesic dome. Okay, the 1996 Nobel Prize in Chemistry was awarded to R. Snelly and R. Pearl for the discovery of Fullerenes. Okay, preparation of Fullerenes. Okay, Fullerenes are newly allotropes. Allotropes of carbon. Allotropes of carbon. Okay, which discovered in 19 which were discovered in 1980. Okay? These are molecular and have spherical cell structure. Molecular and spherical. Molecular and spherical cell structure.
Next, critical velocity.
Structure, spherical cell structure. Okay?
Velocity.
Preparation of Fullerene. Preparation of Fullerene. Okay? Fullerene can be prepared by two important methods. First method, Wolfgang, Krasmar, Donald Hoffman, all method. Okay. It is prepared by passing a large electric current through graphite rods in the atmosphere of inert gas. It is prepared by passing a large electric current through graphite rods in the atmosphere of inert gas is the rod get evaporated to form a light condensate called Fullerenes soup. Okay, it is a colloidal mixture of many Fullerene molecules and carbon. It is then dissolved in benzene organic solvent. From this solution, pure C60 and C70 can be isolated by column chromatography using alumina column. Okay, the C60 fraction is of the magenta color while C70 is orange. Okay, it is prepared by passing a large electric current passing a large electric current through graphite rods in the atmosphere of inert gas. In the atmosphere of inert gas. Okay, inert gas helium, or the inert gas helium. Okay, the rod gets evaporated. The rods get evaporated to form a light condensate. To form a light condensate called Fullerene soup. Okay, it is a colloidal mixture of many Fullerenes. It is a colloidal mixture of many. It is a colloidal mixture of many Fullerenes molecules and carbons. Okay, it is then dissolved in benzene. It is then dissolved in benzene. Organic. Okay, organic solvent, benzene organic solvent. Okay, form this solution pure. Form this solution pure C60, carbon 60 and carbon 70 can be isolated by column chromatography. Okay, using alumina column. Using alumina column. Okay. okay, using alumina column. The carbon 60 fraction, the carbon 60 fraction is of magneta, color, while C70 is orange, C70 is orange, okay? Okay, next heading, protocol and smelling method, second heading, protocol and smelling method. In this method, Fullerenes can be prepared by passing laser rays associated with high energy in the mixture of graphite vapor and inert helium gas. After the discovery of fullerene in laboratory, geologists have discovered fluorescence in nature in the meteorite. Fullerenes have also been found to occur naturally in the shunt rocks. Fullerene having C70, C90 and C120 also have been discovered. Okay. After discovery of fullerene, okay, in this method, fullerenes can be prepared. Fullerenes can be prepared by passing laser rays associated with high energy in the mixture of graphite vapor and inert helium gas Okay. After the discovery of fullerene in laboratory, geologists have discovered fullerenes in nature in the meteorite. Okay. Okay. After the discovery of fullerenes in laboratory, geologists have discovered fullerenes in nature in the meteorite. Fullerenes have also been found to occur naturally in some rocks. Okay. Fullerenes having C70 carbon 70 carbon 90 and carbon 120 also have been discovered. Also have been discovered. Also have been discovered. Okay. Okay. Structure of carbon 60. Next, structure of carbon 60 molecules. Okay. Structure of carbon 60 molecules. 1 minute. Structure of carbon 60 molecule. Structure of carbon 60 molecule. Okay. The most common fluorine carbon 60 molecules look like a saucer ball. Okay, a saucer ball. These molecules are shaped like teeny saucer balls called buckyballs. Okay, with an atom of carbon at each point where the lines on saucer balls would normally meet. It consists of a fused system of 5 and 6 membered rings. Okay, carbon 60 fluorine contains 20 hexagon. Carbon 60 fluorine carbon 60 fluorine contains 20 hexagon, 20 hexagons and 12 pentagon, 12 pentagons, 12 pentagons of sp2 hybridized carbon atom. Okay, carbon atom. Okay, in carbon 60 all the carbon atoms are equivalent by symmetry. In carbon 60 there are both single and double bonds with carbon distance of 1.453 angstrom and 1.38 angstrom respectively. Okay, carbon 60 is strand molecule but it shows great kinetic stability. However, fluorine are thermodynamically less stable than the diamond and graphite. Okay, fluorines are thermodynamically less stable than diamond and graphite. Okay, the diameter of ball cage is 6 to 10 times the diameter of ball cage. Diameter of ball cage is 6 to 10 times as large as hydrogen atoms, as large as hydrogen atom. Okay, the ball cages are stable up to the ball cages are stable. The ball cages are stable up to 1102 degrees Celsius. Okay, this isomer of carbon differs from diamond and graphite, which form lattices where it form discrete molecules being giant crystals structures, okay, network solids. Both diamonds and graphite are insoluble in liquid solvent, but fluorine is soluble in suitable organic solvents such as benzene. Okay. Both diamond and graphite, both diamond and graphite are insoluble in liquid soluble, are insoluble in liquid solvents, but fluorine is soluble. Fluorine is soluble in suitable organic solvents such as benzene, okay. And structure of carbon-60 mixture of fluorine, hexagon rings around pentagon rings in fluorine. Okay. Next heading. Properties of fluorines. Properties of fullerenes. Properties of fullerenes. Okay. Properties of fullerenes. Okay. Fullerenes have a very interesting chemistry. Okay. Fullerenes have a very interesting chemistry. They can react both with inorganic and organic compounds. The important properties are given as follows. First point. React with both organic and inorganic compounds. React both with organic and inorganic compound. Okay. First point. They are soluble in organic solvents. They are soluble in organic solvents. They are soluble in organic solvents. They can be reduced electrochemically. Fluorine can be react with alkali metals to produce solids such as K3C60. The compounds of is superconductor below 18 Kelvin. Okay. They can be reduced electrochemically. Second point. They can be reduced electrochemically. Fullerenes can react with alkali. Fluorine can react with alkali metals. Okay, to produce solids such as K3C60. The compound is a superconductor below. The compound The compound is superconductor. Superconductor. The compound is superconductor below 18 Kelvin. Okay. Third point. They form unstable hydrocarbon. They form unstable hydrocarbon type. Hydrocarbon. Okay. Hydrocarbon type compounds. Hydrocarbon type compounds by reaction with hydrogen. Okay. 2C60 plus R27H2 that make unstable hydrocarbon C60H18 plus C60H36. Okay. Fourth point. These substances are good conductor of electricity and are very reactive. Okay. These substances are good conductor of electricity, good conductor of electricity and are very reactive. Okay. Point 5. Okay. Point 5. Okay. It also forms platinum complexes. It also forms platinum complexes. This point, due to unsaturation, they show addition reactions. They show addition reaction. C60 plus 30F2 that makes C60F60. Okay. Second point. They demerize in presence of cation. They demerize in presence of KCM. Okay. 260 KCM that makes C120. Use of Fullerenes. Use of Fullerenes. Okay. They are wonderful lubricants. This is due to the fact that the balls can easily roll between the surface. Okay. They are wonderful lubricants This is due to this is due to this is due to the fact that the fact that the balls can easily roll between the surface. Second point. Alkali metals compound of carbon 60 are superconducting material. Alkali metals compounds of carbon 60 are superconducting material superconducting material 10 to 40 Kelvin. Okay. Third point. They are used as friction. They are used as friction, vacuum and pressure. Vacuum and pressure resistor in rockets and missiles. Okay. They are used as friction, vacuum and pressure resistor in rocket and missile. Okay. In rocket and missile. Next heading carbides. Okay. Carbides. The binary compounds which are formed by combination of carbon and less electronegative elements are called carbides. Okay. The binary compounds which are formed by combination of carbon and less electronegative element and less electronegative elements are called carbides. Okay. Thus the carbides are binary compounds of carbon with more electropositive elements. Okay. Thus the carbides are binary compounds of carbon with more electropositive elements. Thus the carbides are binary compounds. Thus the carbides are binary compounds of carbon with more electropositive elements. Of carbon thus the carbides are binary compounds of carbon with more electropositive elements. Electropositive elements. Example: CSC2, Al4C3, B2C, etc.
The binary compounds which are found by combination of carbon and less electronegative elements are called carbides. Thus, the carbides are binary compounds of carbon with more electropositive elements. Example: calcium carbide CaC2, Al4, Al4C3, Be2C, etc. Okay? Classification. Classification. Okay? Classification. Carbides differ widely in properties depending on the type of linkage present. On the basis of linkage involved, the carbides are classified as follows. First point: ionic or electrovalent or salt-like carbides. Ionic or electrovalent or salt-like carbides. Okay. Second, covalent carbides. Covalent carbide. Third, covalent carbide. Third, industrial or metallic carbides. Industrial carbides. Industrial or metallic carbides. Or metallic carbides. Okay, these are discussed one by one as follows. First point: ionic carbide. Okay, ionic carbides. Okay, these are formed by the metals of group 1st, 2nd, and 13 except boron. Okay, these are formed by metals of group 1st, 2nd, and 13 except boron. Okay, except boron. They are prepared by heating ether. They are prepared by heating either the metals are there with their oxides with carbon are by treating compounds of the metals with acetylene. Okay, these are found by the metals of group 1st, 2nd, and 13 except boron. They are prepared by heating ether. Heating either the metals are their oxides with carbon or by treating compounds of the metals with acetylene. Okay, then to be beryllium plus carbon heated, and that make beryllium carbide Be2C, and CaO calcium oxide plus 3C after heating that gave CaC2 calcium carbide plus CO carbon monoxide, and 2Li lithium plus 2 CO carbon monoxide at heating that make Li2C2 lithium carbide plus oxygen and 4 lithium plus C2H2 heating that gave as compound as a form of compound Li2C2 plus 2 LiH, okay, and 4Al plus 3C after heating that make Al4C3, okay, Al4C3 and 2BeO plus 3C that make that heating at 1900 to 2000 degrees Celsius, 2000 degrees Celsius that make Be2C, beryllium carbide plus 2CO carbon monoxide, okay. This is the carbide. What is carbide? You can listen carefully about carbide. The binary compounds which are found by combination of carbon and less electronegative elements are called carbides. Thus, the carbides are binary compounds of carbon with the more electropositive elements, calcium carbide, Al4 aluminum carbide, and Be2C beryllium carbide. Okay. Classification: ionic are electrovalent or salt-like carbides. Covalent carbides: first, ionic are electrovalent or salt-like carbides. Second, covalent carbides, and third is interstitial or metallic carbides. Okay, ionic carbides. These are formed by the metal of group 1st, 2nd, and 13 except borane. They are prepared by heating either the metals or their oxides with carbon or by treating compounds of the metals with acetylene. Okay, and that example of carbides. And next heading is properties of carbides. Okay, next is properties of carbides. Okay, next heading properties of carbide. You can see properties. You can see properties. Okay, first point, carbide. These carbides form a transparent colorless crystal. Okay, these carbides form transparent. This carbide forms transparent, colorless crystal. Transparent, colorless crystals. Okay. Second point. These are non-conductors of electricity. These are non-conductors. These are non-conductors of electricity. Okay, these are non-conductors of electricity. Third point, they combine with nitrogen when heated in it. Okay, they combine with nitrogen. They combine with nitrogen when heated in it. When heated in it. Okay, as example, CaC2 plus nitrogen that make CaCN2 plus C. They combine with nitrogen when heated in it. Okay, next. Okay, and you can see 1 minute. Fourth point 4. Okay, they are able to reduce magnesium oxide to manganese. Okay, they are able to reduce MgO to Mg. Okay, 3 MgO plus calcium carbide CaC2 that make 3 Mg plus calcium oxide CaO plus 2 CO carbon monoxide. Okay, fifth point, they are easily hydrolyzed by water or dilute acid to give different hydrocarbons. Okay, the salt-like carbides are further classified according to the hydrocarbons which they produce on hydrolysis. Hence, these carbides can be classified into the following types. Point A, methanides, methanides. Okay, these are those salt-like carbides which yield methane or hydrolysis. Methane hydrolysis, Be2C plus 4H2O. 4H2O, that makes 2BeOH whole twice plus CH4, methane. Okay, and Al4C3 plus 12H2O, that makes 4AlOH whole thrice plus 3CH4. Okay, these carbides contain C4 to C3 ions group. Okay, these carbides contain C4 negative, C to the 4 negative are C3 4 negative ions group. Okay, the carbides of beryllium and aluminum give methane or reaction with water. Since these carbides contains C4 negative ions, hence these are called methanides. These are called methanides. Okay, these are called methanides. Okay, B point. Point B. Point B, acetylides. 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 Okay, acetylides. Okay, acetylides. These are those ionic carbides. These are those ionic carbides which produce acetylene or hydrolysis. Okay, these are those ionic carbides. These are those ionic. These are those ionic carbides. These are those ionic carbides which produce acetylene. Okay, which produce acetylene. Okay, or hydrolysis. Okay, acetylides. These are those ionic carbides which produce acetylene or hydrolysis. Okay, as example, CaC2 plus 2H2O, that makes CaOH whole twice plus C2H2. Okay, C2H2. Okay, and next shading, next example, Al2C6 plus 6H2O, that makes 2AlOH whole twice plus 3C2H2. Okay, these carbides contain C2 negative or carbon triple bond, carbon 2 negative ions or groups. Okay, acetylides are also found to show extent by the thorium and uranium. Okay, thorium and uranium, as example, THC2 and UC2. Okay, most of the acetylides MC2 has the CaC2 structure. In these acetylides, carbon triple bond, carbon 2 negative ions, carbon triple bond 2 carbons negative ions are situated lengthwise in the same direction along the shell axis. Carbon triple bond carbon. Okay, carbon triple bond carbon bond distance 1.19 angstrom. Okay, this causes distortion from the cubic symmetry to the trigonal symmetry with one axis longer than the other two. Okay. These acetylides have a NaCl type sodium chloride type of lattice in calcium carbide. Ca plus 2 is replacing sodium plus ion, sodium positive ion, and carbon 2 negative ion is replacing chlorine negative ion. Okay. In calcium carbide CaC2, C2 in calcium carbide CaC2, the elongated shape of the carbon triple bond carbon O2 negative ion causes tetragonal distortion of the unit cell. Hence, the unit cell elongates in one direction. The structure of calcium carbide CaC2 has been allylides. C points. Allylides. Point C. Allylides. 1 minute. Point C. Point C, allylides. Point C. Point C, allylides. Point C, allylides. Allylides. Point C, allylides. Okay? Allylides. The ionic carbides which yield aniline and hydrolysis are called allylides. Only magnesium carbides yield allylides or hydrolysis. Okay. The ionic carbides which yield aniline The ionic carbides which yield aniline and hydrolysis are called allylides. Okay. Only magnesium carbide Mg2C3 yields aniline and hydrolysis. Okay. Mg2C3 plus 4H2O, that make 2MgOH whole twice plus CH3C triple bond CH. This is aniline. Propine. This is aniline. Propine. Okay. Aniline. Propine. Okay. Hence, Mg2C3 is called an allylide type carbide. Allylide type of carbide contains C3-4 ions are groups. Okay, ions are groups. Okay. And D point. Mixed carbides. Okay. Carbides. There is a mixture of hydrocarbons and hydrolysis. The carbides of iron, thorium, and lanthanides group in the mixture of hydrocarbons like acetylene, olefins, and other hydrocarbons also on hydrolysis. Okay. Structure. The ionic carbides possesses ionic lattice in which the metallic cations are packed into the cavities between carbon and ions. Okay. Covalent carbides. Second point, covalent carbide. Okay. Covalent carbide.